Now we'll see carry look ahead adder, which is a faster adder than ripple adder. Okay, so we'll see that. What is the idea is, in one line I will tell you. So in this ripple carry adder, what is going to happen is, so first of all C0 has to be given to this full adder, then C1 comes, then C1 will be input for this full adder. So C1, X1, Y1 are going to be given to full adder, then C2 comes, then C2, X2, Y2 are going to generate C3 carry, then C3, X3, Y3 together are going to generate the final carry C4. That is a 4-bit carry adder, okay, ripple carry adder. But it takes lot of time, right, to get the results propagated to C4. So that's why what we do is, so rather than waiting for C3, so we are going to create a circuit for directly for C4. How you will see, okay. So that is the idea about carry look ahead adder. In that we don't wait for C3, we parallelly, I can say, simultaneously we are going to create, carry 1, carry 2, carry 3. So carry 3 is not going to wait for carry 2 now. Carry 2 is not going to wait for carry 1. Sir, how sir? For that we have to design a circuit. So the logic for that circuit I am going to teach you. For that we are going to have two functions. One is generate, second one propagate functions. Okay, don't worry about the names and everything. So they are not important for us. So and idea is very simple. Don't worry. The generate is nothing but xi dot yi. Okay. So where xi is nothing but input. See here, x0, y0, x1, y1, x2, y2, x3, y3, right? So here xi, yi is nothing but product of two inputs, xi, yi. I can say ith bit. Now pi is nothing but sum of two inputs, xi, yi, where I represents the ith bit. Okay. Now you tell me what is generally this full adder is doing. The second full adder is adding C1, X1, Y1, correct? Let me do that. Then what is the carry equation? C1 is nothing but, here the carry is nothing but, sorry, the carry is C2, right? So this C2 is nothing but C1 dot X1. Did you remember? So it is nothing but X1 dot Y1 plus C1 dot X1 plus C1 dot Y1. If you have doubt, then you should understand this one. For a full adder, when you have three inputs like this, they are ABC, then the carry equation is AB plus BC plus CA. Okay, I am using this result. Okay, now the carry for this full adder is nothing but C2 equal to X1 Y1. The inputs are like this, A, B, C. X1 Y1 plus X1 C1 plus C1 Y1. Understand? So now if I simplify it, it would become X1 Y1 plus C1. If I take common, then the remaining thing would be X1 plus Y1 into C1, right? So C2 equation is depending on C1. So X1, Y1 are already available. Only C1 is not available. C1 comes after, C0 is given to this full adder, correct? That is what the dependency. Now how I am going to overcome the dependency, I will tell you. Similarly, try to observe C3's equation. What is C3? Carry out from this full adder, the third one. So C3 equal to C now. So the C3 equal to, carry of C2, X2, Y2. That would be formula for that is X2, Y2 plus, did you remember? X2 C2 plus Y2 C2, correct? So it is nothing but X2 Y2 plus, if I take C2 common, it would be X2 plus Y2, right? So I can write like this, X2 Y2 plus X2 plus Y2 into C2. Of course both are same. Now if you observe one thing, X2 Y2 is nothing but, see, Gi, correct? G2, and xi plus yi is pi, then x2 plus y2 is p2, correct? Then I can replace this with g2 plus p2 into c2. So what I want to say finally is, this gi is available, so initially itself, right? Similarly pi is also always available because we have x1 x2 x1 y1 x2 y2 everything, right? So when you have all these available, then gi function, pi function is available, okay, everything. The only thing unavailable is C2. Example, for C3, C2 is available, not available. Still we have a problem, right? So how to solve it? Sir, how you eliminate C2? If you don't eliminate C2, then the problem will persist. That means again we have to wait for C2. For that, what we are going to do is like this. First we write equation for any Ci plus 1. So any Ci plus 1 with that observation is nothing but, so just recall, it is Gi plus Pi into Ci, right? So this is the equation number 1. This is, now let's recall what is C3. Let's take I value 2. C3 equal to C3 equal to G2 plus P2 C2. If I simplify it, G2 is nothing but x2 y2 plus P2 is nothing but x2 plus y2 into C2. What is C2? C2 itself, right? It would be x2 y2 plus x2 c2 plus y2 c2, which is nothing but carry from where? Inputs x2 y2 c2. That is nothing but C3. Yes, perfectly right. So finally what I want to tell you is, this equation is going to help you to find out Ci plus 1 without Ci. How, sir? I will tell you. Try to write first C0. You slowly understand it. So of course C0 is already available. So C1, what is C1? When I value 0, C1 equal to G0 plus P0 into C0. Assume that, let's say, G0 P0 are available with us. Yes, they are available. So C0 also available. Now we try to write equation for C2 first. C2 equal to G1 plus P1 C1. But C1 is not available, sir. Then replace C1 with available things. C1 is already available because C0 is available, P0 is available. P0 is nothing but x0 plus y0 available. So G0, which is nothing but x0 y0, both are available. Then we can apply and between them, right? So that's why all we can calculate. Let's postpone that calculation later. So here I remove C1 and I write the equation for C1, which is G0 plus P0 C0. So that would become G1 plus P1 into C1. C1 is nothing but G0 plus P0 C0. Let's simplify it. You get G1 plus P1 G0, right, plus P1 into P0 C0. P1 P0 into C0. Okay. So finally C2 can be calculated using C0, right? Sir, but we want finally C4, right? What is the equation for C4? I will tell you. Let's begin with first C3. So what is the equation for C3? We know that, right? It is first G2 plus P2 C2. But what is G2? We have G2 already. Don't expand it. P2 we have already. So only C2 is not available. But C2 is nothing but, with respect to this one, G1, let's substitute. G1 plus P1 G0 plus P1 P0 C0. Okay. So let's simplify it. You get G2 plus P2 G1 plus P2 P1 G0 P2 P1 G0 plus P2 P1 P0 C0. Right. So this is about C3, right? Now C4. So C4 equal to, we know that G3 plus P3 C3. Now let's expand it. G3 plus P3 into C3. C3 is nothing but G2 plus P2 G1 plus P2 P1 G0 plus P2 P1 P0 C0, right? So if I simplify it, you get G3 plus P3 into G2, right, plus P3 into P2 into G1 plus P3 into P2 into P1 into G0 plus P3 P2 P1 P0 C0, right? So what I want to say finally, this carry C4 is nothing but this expression. So this expression's beauty is, we have already G3. G3 is nothing but x3 dot y3. So using one AND gate, I am going to get x3 dot y3, not a problem. Similarly, using P3 is nothing but x3 plus y3. Using OR gate, right, I can get x3 plus y3, of course. So within one gate level, I am going to get G3, P3, P3, P2, P, everything, right? So this is nothing but one expression with some ANDs, some ORs. So this entire expression can be realized with only two levels of gates. That is what I want to say. Two levels of gates. Now we'll see the circuit related to this problem. So finally you got equation for C4, C3, everything, right? So what we are going to do is, So we are going to realize this equation with two levels of circuits. Already I told you, right? If you have a doubt, just try to understand this problem. Example, you have an equation called AB plus BC plus something ACD. How you construct an equation for that? Simple. AB. Assume that this is A, this is B. A dot B. So with two input AND gate. So realize BC. Now after that ACD. Okay, ACD. So you get here ACD, here you get BC, here you get AB, right? After that connect them to 3-pin OR gate. That is what my idea. So with two levels we can realize AB plus BC plus ACD. Not only this one, any equation with only dot and plus, any length of equation. So we can realize with two levels of circuit, but sometimes if the equation is very lengthy like this, then lot of pins are required. Example, here you need one AND gate. That AND gate requires 1, 2, 3, P2, P1, P0, Z. Example, you see this P2, P1, P0, C0. How to realize it? You need a 4-pin AND gate. That is a problem. Okay, so what's the problem with multiple pins? I will tell you. At this moment there should be a limit. Okay, remember it. We can't have 100 pin AND gate. So we can have at most 5 pin, 6 pin, not more than that. Okay, so reason we will see later. At this moment, so this equation can be realized with two levels of circuit. Remember it. So one AND level, second one OR. Okay, next, what is our final problem is given x0, x1, x2, x3, y0, y1, y2, y3, we have to add them, right? Then x3, y3 has to be added. So here C0 is already available. C0, x3, y3 should be added using full adder, correct? Then you have to get sum. That carry will be given here. Then we have to add these three using full adder, right? Here one full adder, here one full adder, here one full adder. In that way. So when you add these three, you get carry, that is C2. C2, x1, y1 should be added. You get carry, that is C3. Then we add them. You get finally C4 carry. Now the question, so far in ripple carry adder, we were waiting for C3 was waiting for C2, C2 was waiting for C1 in that way. Now because of the circuitry, C4, C3, C2, everything will be available immediately once that circuit gives the output, correct? Now we will see when that circuit gives the output. Assume that let's say now we have already that C4, C3, C2, C1 outputs. So C4, already we have C4 output, C3, C2, C1. Okay, then C0 already available. Then only thing we have to compute now, sum. Sir, how to compute sum when inputs are available? The formula is A XOR B XOR C, correct? Where A, B, C are the inputs for which we have to, otherwise digits for which we have to add, we have to construct the sum. Okay, so example here you see, I am going to create a circuit for A XOR B XOR C. I am showing here. So A, B, C are just three variables. Don't worry about this A, B, C. From where they came, don't worry. Okay, I randomly took them. Finally, you realize that we have to find out sum of three digits like x3, y3, c3. Similarly, x2, y2, c2. That is what our problem. I show for some xi, yi, ci. How to calculate sum for that circuit? Simple. Take xi, take yi, apply XOR gate. Okay. Now, using 3 input XOR gate, we can realize easily. Okay. If I assume that let's say we have 3-pin XOR gate, then give xi, yi, ci. You get what? Xi XOR yi XOR ci. That is nothing but sum. Correct? Sum si. Similarly, you have to construct sum for every xi, yi, ci. So you understood, I think, right? That means we have to create this kind of circuit for x0, y0, c0, x1, y1, c1, x2, y2, c2, x3, y3, c3. Done. Now, so then you get sum. But sir, when you get ci, how to construct ci? This one, carry look ahead logic. So for creating ci, so we are going to take all these equations and we are going to create circuits. Okay, circuit like this. Already I told you, right, how to create a circuit for this kind of equations. Once you have circuits, then example, let's say C4. For C4, circuit will be G3 plus P3 G2 plus P3 P2 G1 plus P3 P2 P1 G0 plus P3 P2 P1 P0 C0. Question is, sir, what is G3? Recall. G3 is nothing but, did you remember? X3 into Y3, correct? Where X3, Y3 are the, two digits in our input, which are at third position. So what I'm going to show here, G3 is nothing but X3 dot Y3. So using one AND gate, I can get X3 dot Y3. In the early morning, when you wanted to do addition, then take that, I'm talking about X3 Y3. Take X3 Y3 and them, take X3 Y3 OR them. So you get what? P3 and G3. Similarly, take X2 Y2 bits and them, and take X2 Y2 and OR them. In that way, do for every bit, so that G3, P3, G2, P2, everything will be available. Once all of them are available, then because of this carry look ahead logic, C4, C3, C2, C1 will be parallelly generated. Because of this circuit, C4 will be generated. Because of similar circuits, example, let's say C3, if you realize, otherwise if you construct a circuit for this equation, then we are going to get C3, similarly C2, C1 parallelly, right? None of them is depending on other things. So, but how much time they will take with respect to gate delays, we'll see. On the early morning, first this AND gate, through this AND gate signal should propagate. Similarly, all these AND gates, OR gates are parallelly working. So, after one gate delay, so G3, P3, G2, B2, all GI, PI are available. You should agree that, correct? Once they are available, then they will come to this inner circuits, which are nothing but this circuit. So they are in two levels, right? They are all two level circuits. First level AND, second level OR. After two levels, then we are going to get carries. That means after three levels, 1 plus 2, 3. After three levels, we are going to get all the carries. Once you have carries, then what is the meaning of addition? Any addition, recall. X1, X3, X2, X1, X0, Y3, Y2, Y1, Y0. Addition is nothing but, adding C0, X0, Y0, then you get carry. Already we have carry, then let me write them. So we have to add these 3 bits, these 3 bits, these 3 bits, these 3 bits. That means we have to find sum now. The only that is remaining. Already we have now C0, C1, C2, C3. So how to do the sum? Already I told you, right? We have, if you have XOR gate with 3 input, then give Xi, Yi. Already you have Xi, Yi. Then Ci just now we constructed after 3 levels of propagation. That means after 3 levels of signal propagation, you get Ci. Once you get Ci, Xi, XOR Yi, XOR Ci will give you the answer. Not only one particular one. So it is not one circuit I am saying. This kind of XOR we need 4, right? This is for example, let's say 1 for X3, Y3, C3. Similarly 1 for X2, Y2, C2. Similarly 1 for X1, Y1, C1 in that way. Hope you understand. So 4 circuits are required. So all are going to parallelly, here one circuit, here one circuit, here one circuit, here one circuit. So all are going to provide sum. Now don't ask me, sir, what about carry, final carry? That final carry is already generated by the circuit. You just simply take it. So after 2 levels only, sorry, not 2 levels, 1 plus 2. After 3 levels you get carry. Now after how many levels you get? Sum. The sum you are going to get all at a time. So this sum, this sum, this sum, this sum at a time. And the time is, first ask yourself, when are you going to get this carry C3? You are going to get carry C3. When are you going to get carry C3? Just I explained you right here, after 1 plus 2, 3 levels. Now once you get it, then when you apply this XOR gate, then we are going to get sum. So finally I say, so you need 4 gate levels, correct? 4 gate level delay. Now remember one thing, sometimes in the gate exam, they will clearly mention that so you can't use 3 input XOR gate. Then, so for that we can have 2 input XOR gates, but then you require 2 XOR gates. We will see that model also, second model, okay. So before going to second model, so I would like to add one modification to our equations. I will tell you, don't worry. So this is the idea. Finally you understood one idea. Now the modifications are little bit easy for you now, okay. Now we'll see the modifications. Generally Gi is what? Xi dot Yi, Pi is Xi plus Yi, right. Now what I am going to do is, and Ci plus 1, any carry is nothing but Gi plus Pi Ci, right. Now The modification is, if I take Pi as Xi XR Yi, so you are going to get same logic. Sir, why sir? How Xi plus Yi equal to Xi XR Yi? Not exactly like that, but so the so what happens is, so the logic will become same after substituting this Xi XR Y here. Okay, we will understand that slowly. First of all, what is your problem? Where are you using this Gi and Pi? In carry equations, correct? Now I prove that instead of Xi plus Yi, because we know that why this one is Pi, we know that, right? Why it is Xi plus Yi, you know that. So otherwise, let me show that again. Gi is Xi dot Yi plus Pi was Xi plus Yi into Ci, correct? If you simplify, you get Xi Yi plus Xi Ci plus Yi Ci. This is a carry equation. AB plus BC plus CA, where A, B, C are the inputs and AB plus BC plus CA is a carry, right? Remember that. Now instead of Xi plus Yi, now I am using Xi cross XR Yi. Still you get the same thing. Why? We will see. Substitute and check it out. Ci plus 1 equal to Gi. What I want to say is, in the place of Pi, you write Xi XR Yi. Let's do that. It would be Xi dot Yi as it is plus Pi is nothing but Xi XOR Yi into Ci. Let me simplify. It would be Xi Yi plus, right, A XOR B is AB bar plus A bar B. So Xi XOR Yi I am writing here is nothing but Xi Yi bar plus Xi bar Yi. Remember it, okay? Now let me substitute that. Xi Yi bar plus Xi bar Yi into Ci. Let's simplify. So Xi Yi plus Xi, let me multiply them. Xi Yi bar Ci plus Xi bar Yi Ci. Don't worry, it is very simple. Let's take here Xi common. What happens, we'll see. Xi, if I take common, it would be Yi plus Yi bar dot C. Okay, remember one thing. What is A plus A bar B? A plus A bar B is nothing but A plus A bar into A plus B. So A plus A bar is 1 into A plus B, which is nothing but A plus B. So from now onwards, whenever we have A plus A bar B, we can write A plus B. Here also, Yi plus Yi bar C is nothing but Yi plus C. So I erase this part and I write Yi plus C. Yi plus C. Plus this is as it is. Xi bar Yi Ci. Now let me multiply them. Xi dot Yi plus Xi dot, this is Ci, right? Ci. Xi dot Ci plus Xi bar Yi Ci. Right. Now you see here, again you have Xi bar Yi Ci. Here you have Xi Ci, correct? I take Ci common. So what happens, we'll see. If I take Ci common, I show here. Ci into Xi plus Xi bar. I am taking these two terms, Ci common. Xi plus Xi bar Yi. Same formula. A plus A bar B, A plus B. A plus A bar B equal to A plus B. Xi bar plus, Xi plus Yi into Ci. If I simplify that, you get Ci Xi plus Ci Yi. Let me write it. So this part I am erasing. What I got? I got Ci Xi plus Ci Yi. So is it not again Xi Yi plus Xi Ci plus Xi Ci Yi? This is nothing but carry equation for Xi Yi Ci, correct? So here also carry equation for Xi Yi Ci. Both are same. So from now onwards, safely, whenever you have Xi plus Yi, I can use Xi XR Yi. Sir, why? I will tell you. To understand that, so you should understand another circuit design. So far we know we were doing, sum. Whenever you have sum Xi Yi Ci, we were using 3-pin XR, right? Correct. Now we are going to use only 2-pin XRs. Okay, just see that design. I will tell you the advantage of this design. First of all, you see. First step, we have to generate GI comma PI. Then only we can connect these things to carry look ahead logic, right? Carry look ahead logic. So I'm talking about now every GI PI. That means G0, P0, G1, P1, G2, P2, everything. Question number 1. Sir, what is GI now? GI is nothing but xi dot yi. Okay. Now here in the already you have xi yi. No doubt for you, right? That is what input. Then using the AND gate, we can get xi dot yi, which is nothing but gi. Yes, happy. Now we have to construct pi. That is actually xi plus yi, but now we change the logic. Now pi is xi xr yi. If I use that, what is going to happen? You see, I take that xi input, yi input, and I construct to a 2 input xr. Connect to 2 input xr. Then we are going to get here, see, xi xr yi here. If I take this cable, right? If I take signal from here, that would be what? xi xr yi, of course pi. That's why, correct? Now this GI PI got generated using one AND gate, one XOR circuit. The beauty is now that XOR gate, that output also connected to one more XOR gate along with CI. Don't ask me how to get CI, already I taught you, correct? For that, see, from here you are going to get it, okay? So it's not only fixed CI, all C0, C1, C2, C3, everything. So that's why. So CI we are going to get from here. So once you get it, then from here you are going to get xi xr yi. So what is our final goal? Only realizing sum, because this logic is generating carries. So addition is nothing but generating sum bits, carry bits. Already carry bits got generated. Once carry bit is generated, then use that carry bit and get xi xr yi from here. Apply one more xr. We are going to get here xi xr yi xr ci. That is what we have to realize. We are realizing here. Now in this model, so we are using only 2 input gates, correct? That is one thing. Now circuitry also reduced. In the previous problem, we were using one AND gate for xi yi, one OR gate for xi yi, and separate XOR gate. But here we are using now one AND gate for xi yi, one XOR gate for creating some xi xr yi, but same XOR gates output we are using for pi. In that way we are reusing and we are reducing the circuitry, correct? Now that's why it is a better design. Now in the gate exam, if they ask a question, don't worry, they will tell you what kind of circuit they are using, okay? Otherwise somehow you can guess it. They will tell you that what type of gates we have to use. If they say only 2 input gates, probably you can go with this. Okay, if they say yes, you can use 3 inputs, then you can go for that model, not a problem. These are all different ideas. Okay, now here what is the advantage I am seeing if you compare with the previous one? I have all 2 pin gates. Sometimes generally most of the times, so we will be having only 2 pin gates. Okay, so if that is the case, then we have to go for this design. That model will not work, correct? So when you instead of 3 pin gate, of course 3, whenever you have any 3 input XOR circuit, we can realize that with 2 input also. How, sir? Example, your target is what? A XOR B XOR C. So one design is give A, B, C to only one XOR circuit. Okay, this is XOR. Then what are you going to get? A XOR B XOR C. That is one thing. But let's say it is not allowed. Then you can go for first A XOR B, right? Then take C, connect these two to again one more XOR. That's it. Then how many gates are required? 2. Correct? Now, if this is not allowed, because in this we have 3 input gates, right? Then only 2 inputs are allowed. We will be going for this model. When you go for this model, then if you use instead of xi xr yi, xi dot yi, what is going to happen is you will be wasting one more AND gate. Correct or not? Because this is xi plus yi. If you use xi plus yi, what is going to happen? For xi dot yi, one AND gate compulsory. For xi plus yi, one OR gate is required. And these two for sum. So finally 1, 2, this is for gi, this is for pi, this is for I mean these two XORs for sum. Finally 1, 2, 3, 4, 4 gates, right? Now I am reducing these to 3 only. If you write Pi equal to Xi XOR Yi, that is the only purpose we use now this formula. That's it. Better design. Now we'll see the delay in this model. What is the delay? First, in the early morning when you start computation, first inputs will propagate through this AND gate, correct? Now same inputs will propagate through this XOR gate. Once one AND gate, one XOR gate, through that two gates, once inputs propagate, so they generate Gi comma Pi. Once you get Gi Pi, so we will be connecting them to CL logic. So then that CL logic is going to give you appropriate carry, right? Ci. So how much time it will take for you to get Ci? Simple. One AND gate delay, one XOR gate delay. After that, let's assume that, let's say XOR and AND are having same delay. Then one gate delay. After one gate delay, you will come to CL logic, carrier look ahead logic. Here there is how many levels of logic you have? 2 levels of logic, right? So 1 plus 2, again 3 levels of logic. After 3 levels of propagation, this carry is going to come. By that time your Xi XOR Yi is available, correct or not? Because in the early morning itself you have Xi Yi. When you are spending 3 levels of time to generate Ci, by that time this Xi XOR Yi require only one level of delay. After one level itself we will be creating. Don't think like this, sir, this XOR is waiting for this input to come. No. So this output, first of all, Xi Yi will be parallelly connected to this gate also. Within one gate delay we are going to get Xi XOR Yi. Now that Xi XOR Yi is waiting for another partner. Who is that? Ci, who is going to come after 3 gate delays. So now we don't add them 3 plus 1, don't say 3 plus 1, correct? Because this 1 gate delay is a part of this 3 gate delay, correct or not? So that's why 3 gate delays, after 3 gate delays you are going to get sum. That's it, correct? Sorry, plus you have to count this XOR. 3 plus 1, 4. Here also 4 gate delays. Let me summarize. Start. 1 AND gate delay, 1 XOR gate parallelly. Because of that, within 1 gate delay, so Gi Pi will be prepared. After that, 2 levels of logic is there here. Then 1 plus 2, 3. After 3 levels of delay, so you get carry. Then this Xi XOR Yi will be XORed with XOR to get the sum, one more gate delay. So 4 gate delays is the answer. In the previous problem also the same answer, right? Now in the gate exam, based on the question, we have to answer. But this is the foundation. Once you understand the foundation, then you can solve any problem. Sometimes they say that XOR gates are not allowed. Remember one thing, generally XOR gate will not have delay like AND gate. So remember one thing, if AND gate has 1 gate delay, XOR gate will have double delay. That means 2 gate delay. Of course it's only 1 gate delay, but the delay will be double. But in the problem they will mention. I'm just for what I want to say is, why I'm giving this information, because when you have this information you will have better clarity. Remember one thing, in the reality AND gates will be faster than XOR gates. Example, let's say AND gate has 1 nanosecond delay, XOR is going to have 2 nanosecond or 3 nanosecond. That is one thing. Second thing, in the gate exam sometimes they say XOR gates are not available. Then how to have a functionality of XOR? We can have functionality of XOR with AND and OR gates. For that you require 2 levels of gates. You will be studying that in digital logic. Then in digital logic, so please prepare digital logic. In the digital logic already you have studied how to implement XOR using NAND gates, and otherwise AND and OR. Use that logic. Okay, I don't want to mess up the things at this moment, but XOR can be realized with AND and OR and NAND, NOR. So use that. Depends on the problem. If they don't mention anything, directly we use this idea. Okay, these are all the things. End of the day, what I want to tell you is, so in computer organization, once you have foundation, now you understand one level of foundation. Now if you solve the problems, then you will understand the remaining details. Okay, so while solving the problems, if you face the problems, don't worry, that is part of the game. If everyone, see, once you attend this lecture and you always, if you are solving the problems, then everyone will solve the problem. It's not like that, right? So once you understand the concept, now you have a strong foundation about carrier look ahead adders, correct? After that, take the previous gate problems and now start solving. Now apply your brain. Then only you get better rank, and you will be solving the problems really in the next exam, right? So practice is very important, remember it.